Welcome to yet another exciting educational video brought to you by Upvision Concepts Academy. So today we will be looking at flame tests and chemical tests still under laboratory techniques and safety. In this video we will look at introduction to flame tests, what is flame tests, and chemical tests for cations and for metals. Then we will see tests for ions, negative ions, and the gas tests. So sit tight. If you have not subscribed to our channel, kindly subscribe to our channel to get more content on STEMs. Okay, so we dive into what we have for today. So as a way of introduction, I will start by saying that flame tests and chemical tests are essential laboratory techniques used to identify the presence of certain metals like ions and or chemical compounds in the sample. So sometimes you'll be given a sample, some unidentified sample, and we'll conduct some tests to show the presence of a particular chemical or metal ion or anions. So we need to know properties of some of these metal ions or anions. We need to know properties so that by the time we start seeing these properties displaying while we are making tests, we should be able to say that this is the particular metal ion in this unidentified chemical sample. So it's like a kind of a detective subject or topic. It's very interesting. It stimulates your ability to reason and detect what is present in a particular compound. So these methods are commonly tested in the WAEC and NECO Chemistry practicals. So if you are preparing for these exams, you need this topic for your WAEC. So understanding these tests equips students with practical skills and also prepares them for success. So I will start with what flame test is. So flame tests are used to detect the presence of metal ions based on the color they emit when heated in flame. Very important. So on the board, flame tests are used to detect the presence of metal ions based on the color they emit when heated in a flame. So based on the color when heated in a flame. So how does it work? Okay. So let me just put out the procedure. How flame tests work. Okay, so we'll look at how flame tests work. So the first thing to do is that a metal salt, usually a chloride, is introduced in a non-luminous Bunsen flame. Then the heat excites the metal ions, causing them to emit characteristic colors. These are the colors that we'll look at. Okay, so a platinum or nichrome wire is cleaned in the hydrochloric acid dipped into the salt and placed into the flame. Okay, now, so if, for instance, you heat that metal salt and these colors come out, for instance, bright color or bright yellow flame denotes that there is a sodium ion inside that emission, sodium ion. So the goal is for you to recognize all these ions and the corresponding flame, the color that comes from the burning of the metal salt. So sodium ion emits bright yellow. So when you see bright yellow flame, that is the indication of sodium ion present. Okay. So if you see potassium ion coming out, that means you will see a lilac or pale violet flame. Calcium ion emits brick red flame. Barium ion emits apple green flame. Copper ion emits blue green flame. Lithium ion emits crimson red, and strontium ion emits bright red. So note that these flame tests are only for metal ions. Okay, so for metal ions, that's where you do flame test, and they produce distinguishable colors. So these colors are distinct, and this should be done in a darkened environment for accuracy. And don't go and do it in a place where you'll be confused over the color that is coming out because of the lighting in the place. So let the environment be a little bit darkened so that you can distinguish the colors and name the ions. So just go through this and find a way of internalizing the ions with the corresponding flame color, because you will be using it to determine what metal ion is present in a particular compound. Okay, so here we have a set of chemical tests for cations. We will look at flame tests, and the flame test is just a way of using flames to determine the ions that is present, metal ions that is present in a salt after it's being heated. The color of the flame determines the metal ions. So I've asked us to go and memorize those colors for easy identification. But for chemical tests, these tests typically use sodium hydroxide and ammonium aqueous for tests to observe precipitate formation or solubility. So what we are doing is that we are using either sodium hydroxide aqueous solution or ammonia aqueous solution to observe for precipitate or whether they are soluble. So if I have a cation, calcium ion cation, you see that with sodium hydroxide, there is a white PPT observed, which is insoluble in excess aqueous solution. For ammonium aqueous solution, if you put it there, no PPT, no precipitate, no solid comes out. Now for copper ion, you see that if you put sodium hydroxide, you have a blue precipitate insoluble in excess aqueous solution, and therefore sodium ammonium aqueous solution on calcium copper ion, you see blue PPT dissolve in excess to give deep blue solution. Okay, so if you want to test with sodium hydroxide on ion 2, you see that there's a green PPT, turns brown on standing. After some time, it turns brown. For ammonia aqueous solution on ion 2, you see that the green PPT is observed slightly soluble in excess aqueous solution. For ion 3, you see there are two of them, ion 2 and ion 3, they have different reactions to these aqueous solutions. So ion 3 will react with this sodium hydroxide to give us reddish brown precipitate insoluble in excess aqueous solution, and ion 3 will react with ammonia aqueous solution to produce reddish brown precipitate. So note how all this happens, because you will be given an unknown salt that contains any of this and be told to check with this. If you check with this and you see this, you suspect this. You understand? So that's how it works. So you need to just know how this table is, so that when you are doing it in the lab, if you are seeing all these things, you are knowing what is happening. If I'm putting aqueous solution of sodium hydroxide in a particular salt, and I'm seeing blue PPT insoluble in excess aqueous solution, you know that you are suspecting copper ion. Understand? If I'm putting ammonia aqueous solution in ion 3 and I'm seeing reddish brown PPT, you are suspecting ion 3. Okay, so that is the essence of this. So you need to know this Memorize this. Just know it. Just know. Memorizing is just like a way of saying you should just know. You know what every cation is capable of producing in either this solution or this solution. So this is the first 4. I'm going to give us the last 3 so that we can wrap up this particular session. Okay, so the concluding parts of chemical tests for cations. So continuing, if you want to test for zinc ion with sodium hydroxide aqueous solution, you will get white PPT precipitate soluble in excess and is colorless in the outlook. With ammonia on zinc salts, you will see white PPT soluble in excess aqueous solution. For aluminium salts, if you are mixing it with sodium hydroxide aqueous solution, you will get white PPT soluble in excess. Okay, and for ammonia, it is white PPT soluble in excess. See, if you check these two on sodium hydroxide, they look alike because you're having white PPT soluble in excess, but the distinguishing this thing is here. This one is soluble in excess for ammonium, but insoluble in excess for ammonia. So this is what you are going to use. If you put this one in a salt that contains either of these two, you're not sure of what it is, and you see this reaction first. You are suspecting these two, but you don't know which one is which until you now use this one to test. When you use it to test, you see that, oh, one of them produces soluble in excess, and the other one produces insoluble in excess. So that is the distinguishing parameter. So take note of how it's being done. For ammonium salt on sodium hydroxide, no PPT, but gives off ammonia gas on warming. And ammonia gas, when it comes out, it has a pungent smell. For ammonia, there is nothing is observed. That's why it is blank. Nothing is observed. Okay. So ammonia ion is detected by warming with sodium hydroxide and testing the gas with moist litmus paper. So it turns moist litmus paper blue. Okay, that confirms ammonia. It turns moist. Let me just put it here. It turns blue. Sorry, it turns moist red litmus to blue. All right. Okay, so this is the chemical test for cations. So let us go and discuss the chemical test for ions. That's negative ions. Also, so we're testing for the negative ions. So I have a couple of them on the board, the first 3. So if I have a carbonate ion here, if I add dilute hydrochloric acid and pass gas, okay, first of all, if I add dilute hydrochloric acid, what I will observe is effervescence due to carbon dioxide. Effervescence is like a bubbling sound, bubbling and the sound. Okay, so there's effervescence. If again I also pass the gas into lime water, this lime water, it turns it milky. So look at, there are 2 things I'm doing here. The first thing, if I add dilute acid to this, I get this. Then this gas, if I pass this gas through lime water, it turns milky. It shows that carbonate is present. Okay, so for sulphate, if I add dilute hydrochloric acid and barium chloride, I see a white PPT of barium sulphate. Now if I have a nitrate, for instance, and I add freshly prepared iron sulphate, then concentrated H2SO4 down the side, then there's a brown ring at the junction. Okay, so I'm going to give us the second set of negative ions. Okay, so for these other sets, mostly halogens I have here. So chlorine ion, I have, if you add nitric acid and silver nitrate, what you observe is YPPT, that is of silver chloride, is soluble in ammonia. Okay, so for iodine ion, if I add nitric acid and silver nitrate, what I'll be seeing there is yellow PPT from silver iodide, insoluble in this is iodide. This iodide, I. Okay, so insoluble in water, insoluble in ammonia. So for bromine ion, you have, if I add nitric acid and silver nitrate, I will see cream PPT from silver bromide, partially soluble in. So for most of all the chlorine, iodine, and bromine ions, we are adding both nitric acid and silver nitrate. So the PPT observed different colors. One is giving us white, one is giving us yellow, one is giving us cream. So you see that they are distinct. They are distinct. Okay, so advise us to know all this. The next one we go is the gas test. The gas test. So let's see how gas test is conducted. Okay, so we have gas tests, different gases. If we have hydrogen gas, for instance, test procedure, if you put a burning splint near a gas, there's a pop sound. If you put a burning splint, that is something that is already burning, there's a pop sound. For oxygen, if we set a glowing splint, that is something that is about to start catching fire, the splint relights, so it comes out, showing the presence of oxygen. Oxygen supports the burning of substances. So carbon dioxide, for carbon dioxide, if you bubble through lime water, this one is that it turns lime water milky. This one is very basic. Carbon dioxide through lime water turns lime water milky. For ammonia, if you expose ammonia to moist red litmus paper, it turns blue. If you expose chlorine to moist blue litmus paper, it turns red and then bleaches. So chlorine bleaches. And finally, for hydrogen sulfide, the smell of it is a rotten egg smell. Or if you test with lead nitrate paper, what you see is a black PPT. So all these are the various kind of tests we have seen in this video: the gas test, the anion test, the cation test, and the flame test. So go through them. I've left some past questions and answer in the description. Also in the comment section, you see some past questions as well. Do comment and like our videos. And if you have to subscribe, what are you waiting for? Kindly subscribe to our channel to get new content as it's dropping. So I hope this video has been informative for you, and I'd like to thank you for viewing.